Algebra 1, Day 24. Today we're going to be talking about interpreting scatterplots and what is called the line of best fit. Essentially what this means is we're going to have a discrete function, something that's a bunch of dots, and we're going to try and find the equation of a line that is the closest fit to it. Now usually these scatterplots are going to be real world things like how old is the car versus how much does the repairs cost, or the number of boxes that people are able to see at certain points in the year. So it can be anything. It's usually a real world situation. And what we're trying to do is make an equation that closely approximates that, meaning it's not going to be exact. So that way we can kind of do some predictions about what would happen at a future time. So first let's go ahead and jump into this and get into the notes. So a scatter plot is a graph with points plotted that shows a relationship between two sets of data. This is considered bivariate data. Now, as a side note, bivariate data means two variable data. Don't let that fancy word catch you off guard. Because there are two variables. A trend line, or line of best fit, is a straight line that comes as close as possible to the points on the scatter plot. There are approximately the same number of points above and below the line. Okay, let's look at an example here. And again, I am going to be showing you how to do this in the calculator. So here we have age of car, cost of repairs, right? We got lots of information over here, range, domain. Now, the great thing about doing this in the calculator is that it makes it super easy to find these equations. So for this one, if I was to guess, the way that I would do this, and this is something that you can also do to check your work to make sure the line that you receive goes approximately where you're drawing it, is you're trying to get a line that goes through the most number of points. So notice if I kind of shift it around, it looks like at some points it goes better. So like there is like approximately most of the dots are being touched, right? So that would be my approximate line of best fit. So I would guess something along the lines of, let's see, y equals excuse me. So I would guess that this has an approximate equation somewhere here, right? So what I want to go ahead and do now is I want to start by first generating the line of best fit for the graph. Okay, how do I do that? Well, first I need to write down all these points, okay? So I'm going to clear up a little bit of space. And for each one of these points, I'm going to write down approximately where it's at. So 1, comma, maybe about 180 or so, 2, 220. Now notice I'm just guessing, okay? Not exact. It will never be exact. We cannot see that far into the graph. So don't stress yourself out. Even if you're a couple points off from what I think it is, your equation is going to be very similar, okay? And then over here we have 3, comma, 280, 3, and 350, 4 and 420, 5 and 550, another 5 and 700, 6 and 350, and also a 6 and 800. Okay, so I have all of these. Again, range, domain, always in alphabetical order, L1, L2. Let's drop these into our calculator. Okay, so first thing I'm going to do is I'm going to hit Stat, Edit. Under L1, I'm going to type all of my X's. 1, 2, 3, 3, 4, 5, 5, 6, 6. Okay, now I'm going to go ahead and type in my Y's under L2. 180, 220, 280, 350, 420, 420, 550, 700, 350, 800. All right, so I have that. Now I'm going to go ahead and hit that Stat button, Calc, and I'm going to run a linear regression. Go ahead and calculate that, and it spit out an equation. So I'm going to write that equation down over here on my paper. Y equals 95.13x plus 57.81. Okay. So now I'm going to go ahead and go back over here. I have my graph equation, my approximate equation for my line of best fit. And here they're asking me to predict something. Okay, so here my X was the age, Y was my cost. They want to know for an 8-year-old car, give me an approximation. So I'm just going to name this guy f of x, just so we can remember how to do our function notation. So f of 8 equals 95.13 multiplied by 8 plus 57.81. That's some serious math. So I definitely want to use my calculator, but I can also, since I'm going to be using this for a 15-year-old car as well, go ahead and just plug it in. So that's what I'll do. 95.13x plus 57.81. Enter. Take a look at the graph. Okay, it's a really crazy looking one. Let's look at the table. And they wanted to know where x equals 8. So $818.85. And where x is equal to 15, $1,484.80. All right, so I got those values written in. This is super simple. Don't trick yourself and think this is hard. So up here it says, based on the scatter plot, how much should you expect to pay in repairs for a 4-year-old car? So I'm going to look over here. Looks like approximately 420 if I was just to estimate on the graph. Now, let's go ahead and just write in that pretend line again, our estimate of what that line would be. Okay, going through most of them. So I'm going to look at these answers and I'm going to compare them. So I'm going to look at this 800 one. That's the only one that appears on the graph. So it looks like it's somewhere around there. It's pretty close. So I'd say, okay, I'm comfortable with that. And 15 we obviously can't see. All right, so I want you guys to go ahead and do the same exact thing here. And I want you to take note of the fact of what these look like, okay? But remember, line of best fit, so it may not even necessarily go through there. Might look something like that, okay? See you guys next time.